Aerospace engineering is the primary field from aircraft and spacecraft. Two major branches. One is aeronautical engineering, two is aerospace engineering.
"230 years ago, people began to take the skies by balloon. The first successful airplane flight took place in 1903. In 1973, a satellite was launched to the space by rocket invented by the US.
Assalamualaikum, my name is Ifzan Idham and I would like to present about material used in aircraft fuselage. On early day of aviation, fuselage was built using wood. In 1930, airplane manufacturer started producing fuselage using steel. This metal offered more protection and stability from the previous material is wood. The fuselage is the main structure or body of the aircraft to which all other units attach. It provides spare for the crew, passengers, cargo, most of the accessories. The fuselage of most aircraft are of all metal construction assembled in the monocoque design. Monocoque design relies largely on the strength of the skin or shield to carry the various load. So next, aluminium and titanium fuselage. The aluminium used to make plane is always blended with other metal to make it strong and light. Aluminium fuselage does not corrode as easily as steel. Aluminium is not used on the surface of many supersonic planes because heat generated by the friction from flying at such speed causes aluminium strength to decrease. Aluminium is used on most type of aircraft because it's lightweighting and strong. With the same strength as steel and much lighter, titanium and titanium alloy are ideal material for building aircraft. Titanium also resists corrosion better than both aluminium and steel. Production of airplanes made from titanium is very costly. So that's all for me. Thank you.
Assalamualaikum. Today I want to present about properties of aluminium. Aluminium is a soft, ductile, corrosion resistant and has a high electrical conductivity. Aluminium also has a density around 1/3 that of steel or copper, making it one of the lightest commercially available metals. It also has aluminium doesn't have a high tensile strength. And last, aluminium is fairly resistant to most acid but less resistant to the alkali. Next is aluminium extraction process. First, the bauxite ore is mechanically crushed. The crushed ore is mixed with caustic soda or produce a slurry, which is a watery suspension containing very fine particle of ore. The slurry is pumped into the digester. The slurry is heated to 110 to 270 Celsius under a pressure of 340 kPa. The hot slurry, which is now a sodium aluminate solution, passes through a series of flash tanks that reduce the pressure and recover heat that can be reused in the refining process. Next, the hot slurry is then passes through a series of flash tanks that reduce the pressure and recover heat that can be reused in the refining process. The slurry is pumped into the settling tank. Then in the settling tank, impurities that will not dissolve in the caustic soda settle to the bottom of the vessel. The residue is called red mud that accumulate in the bottom of the tank consists of fine like sand, iron oxide, and oxide of trace element like titanium. The remaining liquid, which looks somewhat like coffee, is pumped through a series of cloth filters. Okay, thank you.
My name is Fatin Syahmi bin Ahmad Shukri and my material number is CN1801115. Okay, this time I will explain about previous and current material that we use in build in plane. So for the earlier parts, to build a plane, we use wood to be a material, but it is not strong and heavy like aluminium. But other vintage planes have wooden fuselage in which most of the structure inside the wing are made of the various wooden parts glued together and covered with background like a fiber. Wooden structure tend to be more complicated to make both strong and light. So wood is not very qualification. That's not very useful to be a material in a plane. So, however, wooden aircraft structure don't lend themselves to mass production as they are complex and fuzzy. And we can conclude for this that for the previous material that we use in a plane is wooden is very not suitable for build plane, but wooden has some advantage, which is it's very strong and it's not tan. So that's the advantage for wood, but it's not very suitable for use in a plane. For the current material that we use nowadays is, after almost 2 decades, titanium is used due to its low density, which is 2.7 grams centimeter per cubic. Titanium are commonly used in the construction of aircraft due to its high strength properties, high temperature resistant, and high corrosion resistant compared to steel and aluminium. It is used in panel in civil wing assemblies, hydraulic system, and other parts. Aircraft manufacturing company also favor composite material in the production of aircraft due to their high tensile strength, high corrosion resistance, low weight, and high resistance of corrosion. Composite material improve fuel efficiency and performance to the aircraft. The most common composite material used is fiberglass. It's made up of glass fiber as the base material and asymmetry. So, after 2 decades, we use titanium as a material of a plane because it has good advantage and more reliable than we use wood as a base on material. Fiberglass, and also it's very easy to build a plane. So that's all for previous and current material that we use in a plane. Thank you.
Assalamualaikum. My name is Izul Hafiz bin Zulkifli, and I will continue the presentation about the application of titanium in construction of aircraft wings. A wing is a type of fin that produces lift while moving through air or some other fluid. Wings also have streamlined cross-section that are subject to aerodynamic forces and acts as an airfoils. The wings deflect the airflow downward, turning the air as it passes the wing. Structure of aircraft wing consists of spars, rigs, stringers, ailerons, flaperons, wing flaps, and spoilers. Each of the components have their own purpose for steering the aircraft. Next, I will continue on the manufacturing process of aircraft wings. The aircraft wings manufacturing process begins with the sheets of aluminium comes in the 34 meters of aluminium weight of 5 ton each sheet. The metal sheet will be shaped under the control of contour tape milling machine (CTLM). The machine will cut back across the surface of the wings to reduce the thickness of the aluminium metal sheet. The machine will eliminate about 75% of the panel's weight while maintaining its strength. The wings will be undergo heat treatment to strengthen the structure. The process occurs inside of the pressurized oven measuring at 42 meters long and 6 meters wide, and the wings is vacuum sealed by plastic to protect the metal from any contaminant. The wings was heated up to 150 degree evenly across the wings to avoid any distortion of the wing panel, and it is heated for 24 hours. After complete with the heat treatment, the plastic cover can be opened and the wings now will undergo visual inspection by the authorized inspector. That's all for our presentation. Thank you.